A uniform beam is balanced at midpoint. Here is a midpoint. An object is placed on a beam as shown in figure. So we can see the weight would be acting in downward direction like this, and it is expectedly going to create anti-clockwise movement in it like this. It's an anti-clockwise movement. So we will multiply force with its perpendicular distance, so that can give us anti-clockwise movement. So we can find out anti-clockwise movement like this, which is 60 times 30, and it would become equal to 1800. Okay. Which force will rebalance the beam? So it is we need a clockwise movement with 1800 in magnitude, and the force should be let's suppose the other force can act on the right hand side. So if we increase the distance, like suppose it is 60, 70, whatever, like it's, if its length would be large, its perpendicular distance would be large, then its weight would be small. If we decrease the distance, then its weight must be large. Okay. And the force would be to the right side of the to the right side of pivot. So let's check the left of the midpoint, midpoint and left side. That's totally incorrect. This option is incorrect because it is talking about wrong thing. And there is one more thing, left side of the midpoint, this option is also incorrect. So we cannot consider these two options. These two options are left. Let's discuss them one by one. So there they have the right option, which is right side. So let's calculate the movement generated by this one by one. So 45 times 45, if force is 45 and distance is 45, so it would become 2025. So it looks this option is incorrect because we are looking for 1800. Our clockwise movement should be 1800. Otherwise, there would be an imbalance. Okay, now the next one is 30 Newton force and oh, one more thing is required, which is about downward force. If we are talking about right side, then it should be downward. And if we are talking about the left hand side, it should be upward. So let's see this option. It is 30 times 60 and it would be upward. Here is I made a mistake. 30 Newton force is upward on the right hand side. This is not downward force. It's actually an upward force. If it would be an upward force, That's useless. So if it would be upward, I made a mistake, then it will also create a anti-clockwise movement. So both movements would get added. So this option is not going to be considered. Let me recheck the things. But surely this one is incorrect because of its direction. Okay, so let's revisit one by one. 300 times 600 and acting in upward direction. Upward direction is not acceptable on the right side. Upward is acceptable, but on the right hand side it is not acceptable. So what is our requirement is 1800. It can be, or it can be 1800, and for left side it should be upward. For right side of the pivot it can be downward. So this is our requirement. 1800 is the magnitude of movement. Force should be on the left side in upward direction, and if the force is on the right side it should be in downward direction. So let's visit one by one again. Okay, 30 Newton upward. Okay, for upward it should be on the left side. Yes, it is on the left hand side. Upward force on the left hand side. And now let's calculate their magnitudes. It is 30 newtons times 60 newtons. 30 times 60. Okay, 30 Newton force, and yes, it will give us 1800, and it would be a clockwise movement. Okay, let's move to the next one. 30 Newton upward. Okay, upward 60 centimeter distance, but it would be on right hand side and upward. If it would be on the right hand side and upward in direction, then it will support this one. Both will have a clockwise movement or anti-clockwise movement. That's wrong. This option is not acceptable. 45 Newton force, like 45 times 45, their magnitude is incorrect. So that's why I'm gonna mark it like this. Okay, 90 Newton, and it is a downward in direction. And for downward, it should be on the right hand side. Downward force can be on the right hand side. So you can see it is downward, but it is on the left hand side. So due to left hand side, it is incorrect. So we are left with only one option, which is A. A student finds the center of mass of a triangular lamina PQR. P is here, Q is here, and R is here. He drills a small hole at Q. Okay, a hole is here. He suspended the lamina from a pin through the hole. Okay, the pin is here at Q, so that the lamina swings freely. So it can freely like this, or you can rotate it. He then hangs a plumb line. This is called plumb line. This is called plumb line. Like here is a mass, and it is like connected here. So the weight directly goes in downward direction. So like you can draw a line here to find out the center of mass. He marks the position of the plumb line. Okay, let's mark. the position, like something like this. Okay. What's next? To determine the location of center of mass, the student then repeat the experiment but with one change. What would be the possible change? Suppose plumb line is here. So you can drill on R and we can make, suppose then it would be something, suppose R is somewhere here and it would be something like this. And I'm just making an assumption. Suppose R would be here. And then you can suspend a plumb line like this. And here would be some mess. Okay. The situation would be like this. Then you can turn, like, suppose this time it is R. I'm just telling you like this. It would be R. Then you can repeat this one with P as well. So all three lines, suppose the line which was from Q is going something like this. Similarly, when you will hang around P, the line will go something like this. The point where these three will intersect, that would be the center of mass. This would be the center of mass. Okay, let's move. Okay. What type of the change is required? You can change the holes and then you can find the from every hole. Okay, he uses a longer plumb line. That makes no difference whether it is a small or large. It still remains the plumb line. Okay. He used a heavier weight of plumb line. It also makes no difference. It is always downward. He suspends the lamina from a pinhole through a hole of R. Yes, you can make it with R. You can make it with P, Q, and everyone. Okay, it's possible. He suspends the lamina from the hole at Q with R on the left side and P on the right side. Q. Okay. Let me check. Q on at a hole at Q with R on the left, R at left. Okay, you shift R to this side and P to this side. No, that makes no difference. Like, I think so. This one looks little simple and easy. He suspend the lamina from a pin through a hole at R. So you can change the like this. So to find out the center of mass, you can suspend the this card from each of the corner. Then you can find out the line for each one. Then the point where these cross each other, that would be the center of mass. A metal cone with a circular base is placed on a flat surface. Okay, The stability of the cone depends, like we know the stability is related with the position of center of mass and the base area. The larger the base area, larger and lower the center of, suppose center of mass is here, it would be more stable. If we move center of mass here, less stable, less stable, less stable, and least stable. So if center of mass is lower and the base area is large, then we can expect more stability. Let's look at the possible options. It's weight only, like it doesn't matter. Okay, the diameter of its base, no problem. The position of center of mass, to some extent, it depends on position of center of mass, but we know that the base area is one of the most important thing, so we can't ignore that. So the diameter of its base diameter is linked with area because it's circular. Here is mentioned. So for a circular base, the area is pi r square, or pi r square is the area, or you can say pi d square by 4 is the area. So diameter matters, and because diameter is linked with area and position of center of mass. So position of center of mass. So this is the possible correct option. Okay. Let's move to the next one. The coal is burned as fuel to heat water in a boiler, producing steam. The coal is burned as a fuel to heat water in a boiler to produce steam. The steam drives a turbine which is connected to an electrical generator. Okay. In which order do the major energy transformation takes place? The fuel, okay, let's consider one by one. The fuel is a source, the coal is a source of chemical energy, and then chemical energy is converted into heat. Heat is a type of heat energy, and uh, heat energy is to heat water that produces steam that drives turbine. So when a turbine runs, which is connected to generator to create electrical energy. So at the start, we have chemical energy, and at the end, we have electrical energy. So we have electrical energy. Yes, electrical energy. Yes. So at the start, the coal contains chemical energy. So we are going to consider these two due to the chemical energy. And at the end, we have, look at here, it is talking about generator. So generator is a source of electrical energy. So at the end, we will have electrical energy here and electrical energy here. So the possible option is this one. Okay. Number 25. A wooden trap door is hinged with it. It's a hinge along one side. Okay, it's about a door. When closed, it's supported to the other side by a ledge. Okay, there is a ledge which is going to support the door. Okay. When the door is, when the trap door is closed, when it is closed, the ledge exerts an upward force. So there is an upward force here, which is 15 Newton, and it is from pivot, which is 60. So it can give us a kind of anti-clockwise movement, which is 30 plus 30, 60, 60 times 15. So clockwise movement, oh sorry, it is anti-clockwise movement. So it is 60 times 15. So it is 900. Okay. And there is another weight. Weight is acting from here, acting in downward direction like this. Oh, no, 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 no. Sorry. Pivot is here. So it is going to create a clockwise movement like this. So its perpendicular distance is 30 times weight. So clockwise movement is 30 is the distance and weight. It's a balanced like situation. Then clockwise movement and anti-clockwise movement are equal. We know it very well. So clockwise movement is 30 times W and it is 9,000. So 0 is cancelled with 0. It would be 300. So weight is 300. Now the question is about the mass. So we know that W is mg, which is equal to 300. So G is 10, which is equal to 300. So 0 is cancelled with 0. So mass is 30 kg. Okay. So 30 kg mass is, actually we have 30 kg mass.